Hi everyone, it's Tammy Sherrow, and this is lecture number 2 in a series of 3 lectures on quantitative research. So you should have watched the one on quantitative research designs first, now this one on hypothesis testing, and the third one will be on type 1 and type 2 errors. So just before we get started, to remind you that research hypotheses make the research question testable, and there is no way to statistically model the research hypothesis. It is therefore necessary to define a null hypothesis. And reminder that the null hypothesis states there is no relationship between the variables being tested, so there's no difference exists, and the population is status quo, and any difference that is observed is due to chance. And so it's that hypothesis that is actually tested in an experiment. So let's go on to look at this process. The objectives are to know the process, concepts, and vocabulary of hypothesis testing. You should understand what a research question or a study objective or aim is, understand the research hypothesis versus the null hypothesis, have a good understanding of independent and dependent variables, which we covered at the last lecture, and then we will go on to look at type 1 and type 2 errors in statistical and clinical significance in the next lecture, and we'll touch on effect size as well. So hypothesis testing is a systematic way for us to test claims or ideas about a population. And so hypothesis testing is aimed at prediction. The question to ask when doing hypothesis testing for the researcher is the observed difference that we find likely accounted for by chance or the presence of a treatment effect relationship between the variables? So once again, hypothesis testing is used in quantitative research in either the RCT or the quasi-experimental design. Remember, those are the 2 types where we are testing an intervention. And so we want to do hypothesis testing so we can determine, is the results due to chance or due to the treatment that was applied? So quantitative methods and hypothesis testing, there is 4 steps, and we're going to work through each one of these steps individually. We're going to determine the hypothesis. We're going to identify the level of significance that we set for this particular study. We're going to compute the test statistic, and then we're going to make a decision. Do we reject or retain the hypothesis? And that's going to be based on the results of hypothesis testing. So let's get started with step 1, stating the hypothesis. So we begin by stating a hypothesis which we assume to be true. So that's the researcher's best guess as to the results of the study. So last class we looked at a directional and non-directional hypothesis, and this is what we call the research hypothesis. You might see it also called the alternate hypothesis, but for this purpose of this course, we're calling it the research hypothesis. Then we state the null hypothesis. So this is the starting point. We will test whether this value is true. And once again, the null hypothesis says that there is no difference. And then we're going to conduct the study and gather data to prove that the null hypothesis is likely to be true. So we're gathering the data to be able to say that there is no difference. So let's try and make sense of this testing of the null hypothesis. So all decisions in research are made about the null hypothesis. So the bias is to do nothing. So our bias in research is to accept previous notions of truth. So to accept previous research results as stated by the null hypothesis, than to make claims that are incorrect. So an example is we would prefer to continue with the current standard of care versus adopt a new intervention or treatment that may or may not be effective. And so we always test the null hypothesis as opposed to moving on to adopt a brand new innovative treatment. So the burden or the pressure is on the researcher to demonstrate that the null hypothesis is not true and that the treatment or intervention actually had an effect. So I include these little courtroom analogies. Maybe this will help you understand this concept a little bit more. So similar to the presumption of innocence in a courtroom, the jury starts by assuming the defendant is innocent. And then the decision to be made is this assumption true? And presumed to be innocent is kind of equal to or similar to the null hypothesis. So the burden is then on the prosecutor to show evidence that the defendant is not innocent. So the jury decides whether the defendant is guilty or not guilty based on the evidence gathered and shown or demonstrated. And so the jury would rather let a guilty person go free than send an innocent person to jail. Step 2 is to set the parameters for a successful test or the criteria for your decision. And this is called the level of confidence. Level of confidence that the difference observed between the experimental and the control or standard groups is a real difference. So to set the criteria for a successful decision, we state the level of significance for a test. And this is often referred to as the alpha. And a high quality research article will state this value up front. So when we're appraising research articles, it's a strength for the study to present the alpha value up front. So similar to a courtroom analogy, it's similar to the criterion that jurors use in a criminal trial. Jurors decide whether the evidence presented shows guilt beyond a reasonable doubt. This is the criteria they use. We will use the alpha or the level of significance that's stated before the study is conducted. So in relation to setting these parameters for a successful test or the criteria for a decision, this pre-test level of statistical significance, once again, is called the alpha value or the alpha level. And alpha is calculated by subtracting the level of confidence from 1. And there are 2 standard levels of confidence used in most experimental research, 95% or 99%. So if we take 1 and we subtract 0.95, we would have an alpha level of 0.05. That is certainly the most common. And if the alpha value isn't stated, we assume that the alpha value is set at 0.05. However, I said a strong article will state that. The other value sometimes we use is 1 minus 0.99, an alpha value of 0.01. So just challenge yourself to think about when might we want to set the alpha at 0.01. So we have a very, 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 very small chance or possibility that the results could be due to chance. And I'm going to share an example would be testing of drugs. And so that's commonly used in healthcare, where we might be testing a new drug, a new treatment, a new medication, and we want to be absolutely certain that it is due to the treatment, the changes, not a chance. So step 3, we're going to do our statistical calculations here. We're going to compute the test statistic. And a test statistic tells us how many standard deviations a sample mean is from the population mean. So the larger the value of the test statistic, the further the distance or the number of standard deviations the sample mean is from the population mean. So this allows us to make a decision about the null hypothesis. And there's a little diagram to help you kind of understand that there. 95% being the most common level of confidence we'll set. So step 4 now is we make a decision. And the most important thing is not to confuse alpha with p. You've heard of p-values before. You've all taken statistics before. It was a prereq for this course. But don't confuse alpha with p. Alpha is set before the study. It sets our range that we're going to accept, and p is calculated after. So what is a p-value? Well, a p-value is how likely is it that the result reported in the study is true, accurate, and did not just occur because of chance. So here is where we make the decision as to guilty or not guilty. So when we make this decision, a calculated p-value is compared back to the preset alpha. So if we have a p-value less than 0.05, we reject the null hypothesis that says there was no difference, and we reach what we would call significance or statistical significance. So once again, p less than 0.05, we reject the null and state that we have reached statistical significance. If the p-value is over 0.05, we keep the null. We keep the null stating that there is no difference or the difference is due to chance, and we fail to reach significance. So the decision to reject, kick away, or retain, keep the null hypothesis is called significance or statistical significance. So as I mentioned, I love charts and graphs and tables, and so I created this little table as kind of a quick summary around decisions to reject or retain the null hypothesis. So let's move from the left to the right on the first term. So rejecting the null hypothesis. This means the same as the result is statistically significant. Another way to describe it is the probability of getting a result this extreme or more extreme by chance if the null hypothesis is true is less than 5%. And you would see p-values stated as shown here, less than 0.05, and often if there's a list of different p-values based on different variables in a table or a chart, those that are statistically significant are often designated by the little star. And in a research context, what this might mean is data like this rarely happens by chance, and it is due to our intervention or our treatment. Okay, let's move to the next row in the table. So keeping the null hypothesis, retaining the null hypothesis. So what we've determined is this result is not statistically significant. So in other words, the probability of getting a result like this by chance, if the null hypothesis is true, is greater than or equal to 5%. So here we would say the p-value is greater than 0.05, and sometimes you may see the terms n dot s dot not significant beside that in a research article. And so in this situation, data like this could happen by chance. So statistical versus clinical significance. So often, I guess let's ask the question, can results be statistically significant but not clinically significant, and vice versa? And the answer is yes. Sometimes something might not be determined to be statistically significant, but it still could have significance in the clinical setting. And so we ask ourselves, are the differences big enough to have real meaning? And we're going to look at the article on stress in nursing students in our synchronous session to support your thoughts around statistical versus clinical significance. So how do we determine clinical significance? How do we put value on that? Well, we often think to determine clinical significance, we would consider the impact for the patient or client. Even though it's not statistically significant, could it make a practical or noticeable difference for our patients or clients? Is it costly to implement, or could it be implemented at a low cost, easy to implement, and has practical or noticeable significance? Then we might consider moving ahead with that, even though the study determined it wasn't clinically or statistically significant. So just a little summary of hypothesis testing. For the 4 steps, we're going to state the hypothesis and the null hypothesis. Then we're moving to stating the level of significance. This is the criteria we're going to use to determine the results of our study. We're going to conduct a study with a sample selected from our population. We're going to measure the data and do our statistical calculations and compute a test statistic. And then we're going to make a decision. So once again, we're deciding how the p-value compares to the alpha value and whether our results are due to chance or they are due to our treatment or intervention. All right, thanks for listening. Let's move on to look at lecture number 3 on type 1 and type 2 errors. Thanks for listening.